Uh, Currently, we're looking at the Utron that I'm currently making. It's an 8-inch uh, volume. It's 8 cubic. See, that's the funny thing about an Utron. It's all round and stuff, but it's really cubic. Anyway, that's almost done. The first half of it, and we're gonna be putting some of these big neodymium magnets in there. All right. So over here, we've got our. This is a talk bubble closed loop. All right. And what that is that you got your little comma like thing, and then you got your loop. Your battery is down here on the comma like thing, and it only puts power in when you tell it to. So our cat banks are almost charged up to 12 volts. Then I'm going to throw the switch off and think about how long I want to time the relay for. Here you go, sir. Thank you.
Welcome everybody. What's up, Mike Does?
Hey, Mike. So I got these two SPSTs, and I think I'm gonna put them in series so they go one after the other. Um, we're gonna tie them to this switch with this timer, and we're gonna replace our manual switches with them. Have it all automated. So what the switches are for is right now we're charging the cat banks with this switch. It turns this coil on and it's connected to this battery. Okay, so right now the cat banks in the closed loop are charging. Or the talk bubble. It's either going up pretty consistently. And that's really cool. They're going up pretty same way. One's a really big cat bank, one's not so big.
Thank you for the likes, everybody.
Thank you. All right, so I'm going to turn the switch off right now and close the loop. We're turning the battery power off. So these will start to drain now. They'll both drain really slow.
Let's see if I can get it. There we go.
We can keep the wheel going at about that speed pretty much as long as I keep this relay going. Right now, when I turn this other switch on, the battery that we just used to charge the cat banks is going to charge up. And that's going to be on the other relay. And then I got a signal generator here to boost the charging power. So it's clipping at 120 rate, and it's clipping at this rate too. So it's like double. Seriously, like wham bam, thank you ma'am. Done, over, and in a hurry. I'm on my way. All right. And then right here, we got this coil. I decided to throw this in here. This is my Let's Wire coil. Because in my mind, there's a debate going on. A lot of people might not consider it a debate, but as to whether or not generator coils are useful in any way, shape, or form. So I just threw this in here. It doesn't like tip the balance or anything, but it doesn't hurt it in any way. They do have diodes attached to it, because if you just hooked it up AC wise, it would short out every time it closed. So that would definitely slow the rotor down. A shorted out coil on your system Like every time the switch hits, yeah, that's a problem. I got my piezo transducers.
Nice. So that's when weight's applied, it generates
Sound,
sound.
vibration. So that's
That
gonna
is
be
even
fun.
cooler.
Yeah.
Holy moly.
This is for electric or acoustic guitar and snare drum.
Yeah.
So we're gonna put it on a pulse motor and see what happens.
Let's do it. Welcome in, everybody. Thank you for dropping by. This is Papa Bale. We're working with Pulse Motors this evening. Let us know if you have any questions. Like and subscribe.
So this right here is a total mess. I swear, if you move one freaking thing the wrong direction, you're gonna blow it up. But it's here, and I'll tell you exactly how it's hooked up. This cat bank right here powers all of this. And this cat bank right here is hooked up to this coil. Okay, it's hooked up only this one, just this coil. Right now that coil is off. So right now this closed loop system is running on its own power. It is a cat bank that's running it, but we have control of how much power is in that cat bank at all times, pretty much.
Mike says he's got those same ones.
Oh yeah, hell yeah, man! They're good. 120 amps, 12 volts, exactly what I need. Because all I'm trying to do is replace the manual switches with relay switches. Where was I? Oh yeah, how just this little coil right here and a battery, 12-volt battery, can power all that. Oh, let me get my drawing, because it's real important that I emphasize that the size of these coils are variable. Okay, you can make them whatever size you want, just as long as they're bifilar. They have to be bifilars. And the more that I pay attention to what's going on, I would say the bigger the diameter, the better. I would say this is an alright thickness, actually, for the coil. Just make it a bigger diameter, and you're good. That's what I would say. But, you know, it's a preference, really. Everybody's going to tell you something different. But it's the layers. It's not the turns. It's the amount of layers that you have that contributes to inductance. So the diameter of the coil is going to be the really big issue. Anyway, I found a more linear, smooth way to draw the, you have your power supply, and then the transistors, I drew mirror images. So like the BCE is coming out of the top and the bottom, so I don't have to draw these crazy freaking lines to get to the other side of the transistor. It's on both sides. So it's pretty simple. It's not like this is a magical transistor or anything. It's just a regular BCE transistor that has a mirror image of it, so I can make the lines make sense. It's a lot cleaner this way. You just have to explain that, because that looks like some mystical, magical transistor. It's not. And there it is. Talk bubble. Closed loop system. So this right here is what was on the previous page. And then this right here is that over there. And
All right.
yeah, you virtually have 3 cap banks attached to the same in and out. Yeah. got my trigger strand in my dual drive coil is tied up and plugged into that cap bank right there. So you get the transformer action from the power in, and then the whole system, like the beginning of this coil and the end of the cycle is down here on the trigger. That's all connected to the cap bank as well. So it's doing its. This is about as good as it gets for, keeping itself alive. All right. So what's up, bro? You gonna bring some excitement to the table?
I gotta keep moving, man. I'm getting tingly.
All right, here. Why don't you go sit down, bro?
I don't think I should sit.
Yes, sir. Base collector emitter. Uh-huh. I wish this one was working. It would tell me what level the battery was at. So I'm going to shut down battery gen. And we're going to get the cap banks up a little bit higher. See, it walking around the table like that's kind of tedious, I think. But when we get it up to like 13 volts in the cap banks, it'll be moving really fast. Well, not really fast, but fast within parameters of them being just magnetically coupled. These magnets are just chilling on there right now. They're not glued or anything. All right, so this Utron that I'm making right now, Utron rotor, it's going to house some of those big magnets in it. But if I was to do this in solid 100% PLA, it would cost about $350 to print. So I'm doing 15%. Screw that. Screw that. Oh yeah, it'll be just as fun with 15% and like 100% less dangerous. Yeah, hats off to bro, man. He's the shiznit, man. He helps just for helping out around here, man. He's the bomb. So it's really kind of simple in my mind. We set the timer for either a really fast frequency like a minute or like a 10-minute frequency, and we charge and then we charge. But like the system is not like a foolproof. It's not 100% because it's plugged into the wall. There's no way to do this technically with the batteries that we currently have. So I mean, that initial, see like this right here where we're charging the battery that charges the cap banks, this is what's charging it right here. Hey, what's up, Yanni? Heck yeah, man. Look at my little baby coils. Oh, oh yeah. Check that Litz wire coil out right there, man. That little bad boy is actually picking up quite a bit of energy right now. But I don't know whether it definitely does not, solve the problem of everything draining and everything. We got the cap banks charging up. So this cap bank is this one, and it is charging at a rapid pace, and it's 500,000 microfarad. Hey, hey, what's going on, everybody? Welcome to the channel. All right, so we got primary drive, and this coil is charging this battery when it's up to 12 volts. It's only at 9 volts right now, though. This coil is hooked up to SSG gen mode, and it is charging this battery, and it's using a power supply to do so. It's always at 12 volts. Uh, this coil is hooked up to this power supply, and it currently does not have an output. It's also at 9 volts. This coil is hooked up to this cap bank. This cap bank feeds this whole system. We're up above 13 volts. I'm going to cut that. See, so this way, this wheel is always turning. So when you're swapping the two gen circuits, the wheel doesn't stop. It's not supposed to stop. And I don't think, it's just to make sure that it doesn't stop. Because I don't know, I just kind of went for it with this one. I didn't make sure anything. I see it, as far as I'm concerned, we're genning way more than we're spending in this loop. Even though the things are going down, if I left it in like a 5-minute cycle on the relays, these caps would blow up. Heck yeah, man, we're putting way much more in than we are spending on this wheel right here. It's very cheap to run. Two camp banks can run this thing for 12 hours at that speed. So I mean, I think that's good. I think it's good. And then this one, of course, this is 9 volts parallel. Hallback array. So the magnets on the inside are facing left and right at this point. So they're like this instead of in and out like that. So you spin this one way, it's going to gen more than if you spin it the other way. Basically. Oh, we're almost done. It's almost, the first half of the Utron is almost finished. And I want to show you the bearings that I have for this beast. They're hybrid bearings. It says they go 280,000 RPMs. Of course, we're probably not going to get it going that fast, but at least it can go that fast. See how it has that gap in there? Yeah, man, these are special bearings. And the Utron's gonna go right on this, right on its pedestal, kinda, right here. Gotta make sure those bearings are gonna fit though. Then it was a typo. I didn't misread it. It was definitely a typo. Because I looked at it like 18 times.
Who wants to go out and play?
All right.
Okay. All right. So what are you talking about?
We're talking about the bearings that I got and how they might have made a typo on Amazon's when they said it was 280,000 RPMs.
Oh my jeez. 208,000.
Mike is sure that it's 28,000.
Okay. Yeah.
I don't know, man. I don't know. It's definitely said that. I'm pretty sure that they were wrong now. I mean, I don't know for sure, but I do. We'll see. 28,000 sounds more realistic.
Sorry, I gotta move around, guys. My body's playing tricks on me.
I had it sliding down the pole a second ago. So you don't want to put too much pressure on these ceramics. Yeah, that's going to be really, really cool. With today's tech, right? It could be like 28. Forget the K.
28 RPM.
Yeah, 28 RPMs.
About right.
Selling it. They put it on a plastic lunchbox and they're selling it. Yeah, this one's moving. I've always liked how this particular style that I made 3 of these rotors, these black ones, and they're really light. So if you pack the outside of them with weight, they spin really, really good. They're really, really flat. They came out really, really nice. I can't wait to get this thing, man. This is gonna be great.
That looks pretty cool. Is that copper fuse?
Yeah.
Yeah, dude.
I don't know about. We'll see how much I have left. Cause that was Yeah, no, man. We might not even finish it. Oh, that would suck.
I saw that.
It's gonna be really close. If we don't finish it, I have lots of PLA left, but that'll just not be cool.
Just the tip.
It's gonna be really, really close. So as soon as I set this relay up, I can just forget about it, really. Let's watch it, the first 3 times, make sure that it doesn't like trigger at different times or like trip at the same time so that something happens. Yeah, man. Once we get it down, then I don't see this thing as ever having to stop, really. As long as the power's running at the nuclear power plant, we're all good. And then these power supplies, if I ever get my hands on deep cycle batteries, can be switched out for, batteries that'll last longer. But right now, it's power supply, for sure. But this right now, this is not running on power supply. It's running on these cap banks. So I did mention that this coil right here does not have an output. I was thinking about maybe running an output into the pancake coil through. I gotta find another cap bank or buy another cap bank. But having that output hooked up to the pancake coils, I have two of them right there, and I can like put them on top of each other, wind them in series, and then try and run a pulse motor with them. Because you know the diameter is what's important. It's how many layers you can get out of in your coil. You know, not necessarily how many windings, but how many layers of windings you get. So the diameter ends up being the key factor. Oh, we got it. Did we get it?
It sounds like it.
Oh my God, I think we got it. Oh. Wow, that thing's heavy. Holy smoke. Look at that. Woo! That is nice. All right, so let's get this one in here. Please fit. My God, that's a perfect freaking fit, man. Oh, yeah. Oh, that's so cool. All right, I need a mallet. It's got to be a rubber mallet. All right, we're going to have to make sure that these bearings are good. Oh, wow, dude. Actually, I want to spin it real quick. I'm excited, man. This is... So when I put the top on, all that wobbliness is going to go away. Because I'll have a bearing in the top too, like that. Oh yeah, that's going to be awesome, man. That's going to spin so fantastically. Oh my God, I'm in love. So I was thinking like maybe even a half hour relay. Or maybe 10 minutes. Because you don't want to charge the battery too long. And you don't want to charge the caps too long. Maybe 5.5 minutes. You know, something a little bit longer than high frequency, but something a little bit faster than 30 minutes. And then what will happen is that when one relay's on, the cap bank over there will charge up, and when the other relay's on, the battery that was charging that cap bank will charge up. So the one battery that's fueling this thing will never die. But you know, you are connected to the wall, so it doesn't really count, but it's fun. It's complicated as hell, and it's fun, man. It's great fun to like take it from the wall and then put it through this in 4 different ways and have it come out 4 different ways and have this come out one of those ways and then have it all come back, you know, and then you can cut this off and it's running itself now. So I mean, it's all like really fun and gravy and stuff. Oh, let me turn the signal generator off. The signal generator hits the SSG gen mode with a baseline of 333 hertz. So it's always pulsing when the power's on, but it's also being hit by the 3 magnets in the rotor. So you get a double dose of genning power, a double pulse, if you may. Oh, let's take a look at this Tesla coil right here. This little baby thing. I got this toroid hooked up to it, right? Look at how it eats up the plasma. I'm gonna flip it over. Is the Tesla coil polarized? Let's check it out. See, we're not getting that arc in the bottom now. It's all coming up the top. Nice. Hell yeah, it is, man. And the Tesla coil here is definitely polarized because I wish I had my magnet gun right now. I could tell you this side is what it's attracted to. So when I flip it over, it shoots to this side, and when I flip it up, it shoots to this side. So that's obviously attracted to that side, so it's the opposite. I got these piezos. I'm finally going to check out what these are all about. Uh,
All right, man, I got a poll question.
yeah.
Have you ever purchased a handmade coil online for your do-it-yourself project?
Oh, that's a great question.
64% no, 11 votes.
Wow. Okay.
Some would be yes.
Yeah. Okay. So, I'd like to. I don't know Sky personally, but Sky Collections makes great coils.
You make great coils too, bro.
I make some pretty awesome coils. A lot of them are experimental.
Yes.
Um, these ones over here weigh about 2.5 pounds, so they're not too shabby. But these ones right here are like not even 2 ounces. Now I used to purchase solenoid magnets online before I even wrapped my first coil. I bought and they're specifically called solenoid magnets. Like if you wanted to buy one of these, that's how you would look it up. You want me to turn it up? And the pulse? You want me to turn the pulse up too? Let's flip it over. Okay. I didn't hear any of that. Wow. Thanks, man. So you get a really bright arc of whitish plasma. It's almost like a spark. It's not really like plasma, it's like straight up spark. So I came across a little bit of change and I threw it back at the community. And I've been scoping out members only content in a couple channels. And I'm like blown away, man. This stuff is amazing. Now, I had one of those ionic plasma balls that you could, like, a globe that you could put your hands on, and the plasma would come to your hand and stuff. When I was younger, it cost me like $150 because it was like when those things first came around uh, on the street, kind of. Thanks, Josh. Glad you're here, man. All right, so let's. Wow, that was cool. I think I saw fire. Oh no. Yeah, there's the baby, or the baby Utron. Yeah, the baby Utron. So, and look at how close we were to running out of filament for the print. That's amazing that this actually came out. Hell yeah, Josh. I roll my own. I bought them. I've rolled my own. I've been through a lot of different phases in the grand scheme of things. But you know what this? You know what I call these coils? The broke man's coils. It's like when you have no money and you absolutely have to roll a coil. These will work. It's powerful, man. And I printed these little like drums. These things right here are full of iron powder. Awesome. So they all have cores now, and they run smooth, like really good. I'm happy with it. So really what you want to do is right when it gets around this point right here, even like 11, time how long it takes to do that, because it's not really going to change that much. Get to 11.5 volts and then switch it. Charge your battery back up and stop charging your caps. Or the other way around, whatever. It's hot. There's the water. Looking for the water. Oh my gosh. Oh. All right, and with this fine piece of equipment, I managed to discover the inductance of my dual drive. It's 6.5 microhenries, and that's for one. And so I believe it's 6.5 microhenries parallel would be the correct answer. So it's not 12 or 13 microhenries, it's 6.5 parallel. And the reason that I believe that this is true, oh man, if I only had my little notebook. I'm looking, there it is. This is the what I consider to be the proof that a parallel circuit and a circuit around the same length uh, are not the same inductance by any means, or the same power. So 830 turns parallel is the one on the bottom, and 1660 turns is the one in the middle. And the one in the middle is going to have the more inductance. And that's because it's going to continue on the outside of the coil instead of returning to the middle of the coil or the beginning of the coil. So like the parallel wound in series or connected in series is not as strong as that same length wound continuously. The frequencies are really different. I mean, the coils, that wrap is 100% entirely different. Connecting those two lines in parallel or having this coil, which is 1500 turns single wrap, that coil is mean. It's 20 gauge, 1500 turns. It weighs about 3 pounds with the bobbin, of course. I might have to stop it. Something's not right. Let's look under here and see what we can find. Oh yeah, look at that. What is that? Oh no. All right. All right, I'm gonna have to tape that down. It's coming undone. See, and it doesn't even want to stay still. All right. Yeah, I can't do this with one hand. That is very cool. That is very sensitive. I didn't have to push it at all. It just moved fast. That's a bonus of having a magnetic switch. So what I'm probably going to end up doing is getting rid of this wheel altogether and moving the Utron into its position. So it's an 8-inch Utron. When I print off the top, it's 4 inches down, 8 inch diameter. And it's going to house those big square magnets. Oh, that's going to be so cool. And there, right there, I'm gonna salvage. I've already started salvaging these magnets. You just gotta let the glue dry out a little bit, and then they come right out. Yes, sir. It is a brushless DC motor. These magnets are in a hellback array. Hellback. There's only 3 of them, so it's not complete, but they're all facing that way. When it passes here, they're all facing like this instead of like that. I love this thing, man. It's so responsive. Here, let's stop it and start it. All right. Boom. So smooth. Thank you, sir. Gerald, you too, man. Just the patience it would have taken to wind that geometry coil, I can't imagine. And with those ferrite magnets on the edge, I think we're getting a lot more action from this coil than we would have been without. I can feel it. Oh, see, I think that's coming undone though. This whole rotor, it's built on tape. That's why I don't like it going so fast. Yeah, see, this magnet right here wants to come up. So does this one a little bit. Now, how do we stop it? How do we turn it off? Heck yeah. It's a Litz wire coil too. It's like 100 strands of 38 gauge, 2 ounces of it. But I got 2 diodes on there, so it's not lensing like it usually would. But I don't know how much of that genuine energy is getting through those diodes. Some of it is. So the cap banks get charged up to about 13 volts. And then we stop charging the cap banks and start charging the battery. The only problem is with the whole system, it starts at the wall. That's what it is right now. I'm thinking a deep cycle, deep cell, like the deep battery, like the secret kind or something like that. In place of the power supply. So every once in a while, you gotta take from the wall to charge up the battery that you're charging the cap banks with. And that's what I'm planning on hooking up a relay and replacing these manual switches with a relay. Actually, there are 120-degree magnets here, and they're in a Hellbeck array. So they're facing every time a magnet passes, north-south is going to occur. So you basically have 6 north-south with the Hellbeck array with only 3 magnets. And then let me think here. Yes, it is charging. And yeah, I was thinking more solar for myself, but a wind turbine sounds pretty cool, especially if you got a lot of wind. Well, I live in a trailer park, so yeah, a lot of wind does occur here. It naturally gets channeled in the trailer park, especially the big ones. Like that wind will just blow down the street like at 50 miles an hour. So instead of having all this set up on that little table right there, I was going to have it maybe go along the wall and come up on this over here because I want the Utron to be the rotor that's being in the closed loop. Oh yeah. You know how much these bearings cost? The what do you call them? Hybrid bearings? Oh yeah, the hybrid bearings, $22.95 for one. So I'm not in any hurry to break my bearings. You know what I mean? Yeah, freaking ridiculous. But I was looking at the numbers, and these bearings are spectacular. Uh, See, those are 100% ceramic. They're better than that by a long shot. So cool. And they're built for a wind turbine. So, thank you, sir. Yeah. But yeah, I gotta agree, man. 22 bucks for one is freaking nuts. It's like, oh my God, how do they expect us to do this stuff? And they're like, well, maybe they're deterring you. Man, this one guy was cussing at me in Chinese like so bad that they just left it in Chinese when I asked to translate it. I'm like, God, what did I do? It must be because it's a mess, or there's like some standard here that I'm not living up to. Yeah, good luck. I mean, that's true. Absolutely, man. I mean, I have found, and the baby coils are a perfect example of that, telling them to, F off, because copper is expensive as hell, and you just make a little coil, and boom, you've bypassed all that stuff. Because, I mean, just look at it. 9 volts in, 9.8, 9.4 volts in, and it's going, oh, yeah, I wish I had my tack meter. Usually when I say that, it just pops up. Anyway, it's probably going around, I want to say, in between 600 and 800 RPMs right now. Yeah, Mike, what are you talking about, man? I'm interested what you're talking about. Did I say they? There is no them. There is no they. They is in reference to demonology. No, they is in reference to demonology. They is in reference to the damned. I mean, if you want to break it down, it's biblical, and they are in reference to the damned in the Bible. But, I haven't even read the Bible. This is all on hearsay anyway. No, they is not the powers that be. Mike is awesome. And if I said they, it was coming out of my mouth so fast. I don't like saying they or them. I like to really put a fine point on what I'm trying to say. So if I did say that, and you really got to have legitimate beef, man. You can't just be throwing it out there like that.
Legitimately.
Sound like you've been drinking, Mike.
Pulse motor beef.
I'm gonna tip back a couple myself. Actually, it's freaking hot. No, it's better off for they to keep themselves a secret, especially in my presence. Welcome to the channel, everybody. We're exploring the mystery of they. Who is they? Who is them? neither nor. They become them. That's cool. All right. But yeah, just keep it rolling, I guess. I'm going to hang this up real quick so that I can sit down and relax. There we go. Five hours and 23 minutes to print that Utron. Yeah, I need to cut. I'm going to save the last little bit of that copper. And I'm going to put
10 likes.
nice. Man, that rotor's falling apart though. This big one over here. Anybody want to throw me a suggestion on how to hook these piezos up?
Mike says, I admit it, I'm way too semantical. The semantics. Collins.
Oh. Whatever. It's all good. All right, so I'm going to give the humans an opportunity to help me with my piezos. Right now, I want to know how to hook them up on my system, and I'm giving the human beings an opportunity to tell me how to do it right now. If you can't do it, I'm going straight to chat afterwards. Me and chat are going to sort it out.
Parallel sounds right.
Parallel to what? Coil? Or the circuit? Coil. I'm wagering. All right. Woo! I will try that. Now we want to double it up, right? We want to hook two of them up. Is that a thing? Oh man. I don't know.
Gerald has to dig off.
All right, Gerald. I'll check you later, man. Thanks for stopping by.
Says great job.
All right. So parallel across the coil, just like a BEMF diode, right?
To each other and then to device.
So parallel, so across each other, and then parallel to the device. I got you. All right. So it's like a little parallel train. Thank you. I'll have to actually think about that, how to hook that up. And I gotta buy more clips. I don't have a single clip available to me right now. They're all being used in the current setup. Huh. Maybe if I take the pickup coil out, then that will free up 4 clips.
parallel to the drive coil, I believe, and then he says he's got to go. Talk to you later.
See you later, Mike. Thank you. And the thing is, both of these are the drive coil. So they'd have to go parallel across both of those, I would imagine. But you could hook it up parallel across just the one, but they are linked in series. So I don't know. We'll try just the one at first. And I think those 4 clips will be just enough. And then those piezo's are supposed to increase or amplify by about 30%. I'm gonna have to go out there and get some water. More water. So these were made for an acoustic guitar or drum, snare drum. Oh yeah, I'm not gonna be able to do this tonight, but I will definitely hook these up before I go live next.
The acoustic piezo's.
Yeah. They might be the wrong type of piezo, but we're gonna hook them up and find out for sure. I think an acoustic one would be righteous for like the vibrations coming off the motor.
Yeah.
But it might be, the wrong size or something. We'll find out. I'm definitely gonna find out, but I don't feel like getting all up in there right now. I'll be right back.
There you go.
That's cool.
Cough it out.
Alright, child, we are alive.
He's just whispered it. They can hear you, Caleb.
Probably hear me too or anything
Alright.
Alright.
I think we're gonna be right out here. Starting up a movie.
I'm gonna go eat some potatoes.
You ready? Let's do it.
For what?
Let's start up a movie.
We're gonna watch a movie.
No, go around.
No, they're gonna see me.
Go around, please. Thank you. All right. Well, since my stuff is falling apart currently, I think I'm going to go out there and watch a movie with them, patch everything up for the next time. And what I'm planning on having is the piezos hooked up and the Utron ready to go. It's going to house 4 huge magnets. And it's going to have these hybrid ceramic bearings. Really, really cool. Ah. Oh, speaking of the monopoles, I made a really awesome magnet. I guess you can call it a monopole magnet, but that south is really, really strong in the middle here, and it sticks out this way. And this is north, and this is north. But this in here is really strong. And I have this other piece of iron. It's a little bigger, and it can fit in between these. Kind of like that, and you hold them and tape them together. But this piece of iron is the inside here field, and it is extremely powerful. And like if you were to build a toroid and put a bunch of little magnets around the outside of the disc, like if you do a north-north like this, you will reduce your strength of field by half. You'll have a north facing up and north facing down, but it's going to be half the strength. Because it really is all about how far they can reach. The magnets have a reach, a range of usable field. And when you put north on north, it's like the south eats up half of the north. It's really weird how it happens, but you do get the north-north effect, but it's like it won't. Like if you're levitating something, it won't be as buoyant as having a north-south, north-south. You know, it won't have as much power. Yeah, and I made a north-north magnet just like the one that I was showing you earlier on the edge of the disc with bar magnets. So I put like 4 times as many magnets that are on that one on the one that I'm talking about, and literally you get half the strength on both sides. So that's literally it's not worth it. And the south is still there. It's still there. It's just masked. It's called masking. Um, okay, but the big magnets on the wheel in front of you, right? They have a field that's about 4 inches in front of them, without the ferrite addition. Just them by themselves had 4 inches. And then this big rectangle magnet that I have, this one has 6 inches or 7. So, all right, let's do the math. You got 4 inches and then you got 7 inches, so that's 11 inches. So if you make this big rectangle magnet 10 inches close, that's 1 inch where the field is being compressed. Okay, and you want to see how much force you get out of that compression. And it's just an inch, okay? It's only an inch of field against field, but you're going to get a massive reaction. That's cool, Yanni. Oh man, so good. Water never felt so good. But that rotor right there is falling apart. Let's see if the magnets actually fit. Oh. Oh. Which way do we want to have facing outwards? North? Yes. Good fit. Yeah, I gotta find my, I can't do this in my head right now. I gotta find my magnetic. My little gun that tells me what magnets are what.
Uncle Chris stepped on glass and his.
Why is there glass on my floor?
I don't know.
You do. You drop glasses all the time.
How would I know? What's big and brown?
Alright, so you need to help him. And I'm gonna wrap this up. Yeah, that's unfortunate. There's like a broken ornament piece on the ground. My brother just stepped on it. So it looks like north is going to be facing out. Look at that. That is nice. That is probably going to be just right to do some major damage. It's going to go really fast. This thing weighs. It's awesome. I might have to send one of the bearings back and get another one because it just barely fits. We don't want a situation like this one where they won't come off. So we're going to set this up a different way. See, better? Getting better?
Yeah. It's not dripping on the ground.
So these are little nickel magnets. We're just trying to get it strong enough that it'll catch the switch. See, those big magnets really help. So we'll double or triple up now. There we go. It works. Woo! All right, but we're going to be moving from here over to there, maybe. I got to be able to get that pole out of there. I don't think I'm going to be able to do that. But I only want one pole on that over there. Yeah, there we go. Bada boom. And as far as I believe, as long as the directions don't say you have to use this type of coil and this is why, then you don't have to. Then it's like you can use a pancake coil, or you can use a nickel coil, or you can use a geometry coil, or you can use a rodent coil. You know, there's no like specific rules as to what coil you have to use unless there are specific rules. All right. Thank you. Thank you. All right. Well, I think we're at a natural lull for the night. I think we're going to watch a movie. And I'll catch you all later. Thank you very much. Thanks for the likes. Peace out. Have a great night. Please subscribe. Bye now.